So our presentation is called Training Automation by Hand. So most manufacturing automation that exists in industries today is designed to replace human motion, either to make it more efficient, faster, more precise. And most of that automation requires knowledge of complex programming languages, such as Python, Bash, Perl. There's actually one called General Automation Language, or GAL, and goes on Ruby, Java. Any of you who program are probably familiar with some of these languages. So what happens in that case is the person training the automation is not actually the skilled laborer. It's a software developer. And they have to interpret the motion of that human and then translate that into machine code. So our idea was to rely on Mr. Bozeman's prosthetic control system design patent. And so this patent is for a shoulder harness that is worn by a user, and it interprets shoulder motion, which is a continuous human motion, and translates that into electric signals. And that then controls a prosthetic device. So the idea is actually to flip that around. So we would have a reverse design where the skilled worker could wear a glove that actually fits on their hand, and that interprets their motion, again, interpreting human motion into software outputs. So the idea would be that our product would offer pre-programmed software outputs. So some of the more commonly used languages would be preloaded into the licensed software that someone would buy from us. If that didn't work for their application, we also would have a group of developers who could custom design for them. So again, rather than relying on a developer to do this, they could rely on their own in-house expertise in the skilled labor to train their automation to do what they needed to do. So this is a video that I'm going to play here in a second. So within the industry, Festo is a leader in lab automation. From personal experience, I've actually they have a pretty good presence here in Houston, and at my company, we've recently purchased something from them. But this isn't our idea. This is something that they designed. But the idea, I wanted to show you conceptually just a little bit of what it would look like. So obviously he's wearing a glove. But what he's controlling is the exact same thing that he's wearing. Our concept would be wear the glove, but control the automation that is for their manufacturing process. So you take it. Use of the software they developed here. So in that last little section, one of those hands was his hand inside the device, and the other was the device responding to his motion. So that's the concept that we're going after. One other big difference with ours is also that it would be wireless. And that's going to play a key role later on when we talk about some other technologies that are out there. So conceptually as a product, we would like to offer it at 3 different service levels. So we would have the purchase the system, rely on our software development expertise, or a lot of these companies do have their own developers in-house, and they could use their own developers, their own expertise for the software section, or they could rent the system. And this could be a lower cost alternative, but it might limit how long they can use the instrument. So it really gives a little bit of flexibility to the customer to meet their business needs. So when you look at competing technologies, we actually did a pretty thorough search and found there's a company called Tangis, which works closely with Microsoft, and they do have some patents, this one in particular that I've listed here, but they have several around this concept, and it's more for wearable computing and like Google Glasses or something along those lines. And they have some intellectual property around that. Now, when we looked into our concept and theirs, there wasn't a great deal of overlap, and I think some of the key things that help us are Bozeman's unique design, the design of the instrument and how it translates human motion into electrical signals, and also the concept of making it wireless. So none of their patents highlighted wireless technologies. So both of those give us some freedom to operate. So, development costs. The concept is, we looked at a 10-year time frame for starting up and then starting to make a product. So initially, the initial investment would be $20 million. And the breakdown is seen here. So a lot of it would be in the capital. There's a lot of machining that would need to go on. There's also some concept of 3D printing that could come into play that actually might decrease the cost there. Obviously, you've got overhead, raw materials. The vast majority of it comes in the skilled labor that would be required to do this development. So you would have a pretty sizable team of skilled developers, engineers, software developers, and then there's a handful in the overhead. There's a handful of management as well that would need to go along. So the product life cycle, which Forrest will talk about a little more in detail, in year 4, we would actually start to sell the product. So years 1 through 3 would be all development, and the focus really would be on getting the product ready. So the concept is over time, as we get the product developed, we would get down to about the cost of goods to manufacture one of these would be about 20% of the sales price. And we're looking at about a $25,000 cost per unit.
Andrew, so our analysis wouldn't be complete unless we looked at the external environment in combination with the product that we're trying to make. And so one of our biggest things is the industry that we're trying to enter into. It's a very crowded market. It's something, it's custom computer programming. And so it's something that a lot of firms are in, especially on the consulting side of it. So this firm, or this industry, has grown fairly consistently over the last 5 years and is projected to increase its growth rate in the next 5. So it's a really good environment to be in, even though it's a really highly competitive one. The other thing about this industry is it's mostly made up of sole proprietorships that don't have any employees. And so it's just a single owner operator that has an idea or is able to go in and do some consultancy work. So that should really help us out on the competing front. The other thing about our industry is the largest operator is IBM, and they only have a 6.5% market share. So it's a really diverse and fragmented market. So then we started talking about, well, who are we trying to target with this product? Who are we trying to get to purchase this? And it's such a large range of manufacturing that could do some tactile manufacturing items. Anything that somebody makes with their hands could be done with this item. And so instead of trying to gather all those different things together and try to make a target and say, well, it's going to grow at 5%, we said, well, let's back up. And really, we're trying to make this machine do what we want it to do, or at least give them the ability to do that. And so the industry that actually makes the machines is the power tools and other general purpose machine manufacturing in the US. And so that market is still slotted to grow and increase growth, just like our market is. So both of the industries are really looking positive for our product. The other thing that we found looking into these industries, and also many of the manufacturing industries, is the materials cost in all of them are expected to significantly increase over the next 5 years. And so that push the companies to look for more efficient ways to do the things that they do. So the other thing that we were looking at is that the skilled manufacturing labor, the people that are actually able to do these things, are starting to come into scarce supply, and I believe we'll talk about that a little bit more in the SWOT analysis. So the next item is the product life cycle, which he touched on a little bit earlier. So we're projecting to bring this product out after the third quarter in year 3, which is why we have a slight income in year 3. But we expect it to grow significantly from years 1 through all the way through year 10, and then kind of plateau. And if we don't make any advancements with our product, that's where it's going to stay. So that ties into our net income by year. Years 1 through 3 are where we're spending money to develop the product and the software and all the integration items. So we're really going to have significant investment to keep that up until we can get the product out the door. But year 3 actually almost breaks even once we get the product out in the third quarter. We're expecting $150,000 purchase price for our product and the license combined. We're also anticipating that most people will want to purchase it for a 10-year time frame instead of a by-year or even renting the item for a very short time. So that combines with a $25,000 cost for the complete item, or out of pocket for the consultant firm and for the actual prosthetic device together. And so our profit margin is roughly $125,000 for the year, which totals up to be roughly $600 million over the course of the 10-year time frame with a net present value calculation. So the next piece that we started to talk about was our SWOT analysis. So the strategic positioning that we could do, or some of the actions we could take to mitigate some of the risks that we're facing. So in the strengths that we have, the lack of skilled manufacturing labor that I talked about earlier is a huge driver to this industry. It's something that can either break some of the companies or at least open the door for us to get in and get this product and get it more efficient. So the other piece is the low recurring costs that our customers are going to face. So it is a large initial purchase at $150,000, but they won't incur another cost for this prosthetic or the automation that it lends itself for another 10 years. And then at that point, they have the option of either repurchasing the license or just not using the automation piece to actually create more new automation. So the other flip side of that are the weaknesses that we're facing. And because it is a very crowded market, it's something that a lot of firms are competing for. It's going to make it very difficult for us to differentiate our product from theirs. It's going to be something that we're going to have to engage with personal selling and get out there and really meet the people that can make the decision to make this purchase. And then the initial 3-year time frame for product development also faces a huge risk for us in that if we have cost overruns in the development process, or if there's a time delay, we're going to have either more cash influx, or we're going to have to start planning for a different time frame on implementation. So the opportunities and threat piece, we believe that lean manufacturing right now is a very hot item, something that a lot of companies are looking into and are really wanting to bring to their environments. And so if we can integrate our product in with that lean manufacturing concept and really push that from a marketing standpoint, it can be a huge opportunity for us, and a lot of people we believe buy into it. And the other piece is the manufacturing of the machines themselves. If we can create partnerships with them and start developing the software as they make adjustments or as they bring out the latest and greatest machines, we can actually have our device to a compatible level before the manufacturers ever get the product. And so we'll be, that partnership will really drive our sales in the long run. So the threat's kind of what we talked about earlier with a very crowded industry, and then the potential competing product in the marketplace that where they come out and really are able to undercut us. We would have to keep an eye on that and make sure that our licensing fees, especially over the 10-year time frame, are in at least a reasonable level of theirs. So in conclusion, we think that we have a very solid product that has a very large potential customer base throughout all of the manufacturing industries. The market outlooks for both our industry and the indicator industry are very positive, and our performance and the growth rate for everything that we calculate up came out to be an extremely positive outlook.